everyone. Happy Labor Day. I'm sorry you have to have class today, but at least hopefully you can get to sleep in a little bit today. So today I'm going to start on Chapter 4. Chapter 4 is kind of a long chapter, and it covers supply and demand, which is kind of like the meat and bones of economics. So I'm going to do this in multiple parts so you can kind of make sure you don't get lost here. So today is going to be like part 1 of many parts of Chapter 4. And today we're going to start thinking about demand. So I'll put in parentheses part 1. Okay, so to just kind of set the stage for you, when we plot supply and demand in economics, we do so for individual markets. So each market is going to have its own supply and demand curve, and so it's important to understand what is a market to begin with. So I'm going to give you the definition, and then we'll talk about it. So the definition of market is a group of buyers and sellers of a particular good or service. So a group of buyers and sellers of a particular good or service. Okay, there's 3 important things to just note in this definition. One is that each good or each service gets its own market. So we're going to try to silo things up so that we can look at individual markets. So we can look at the market for t-shirts and pencils and puppies, but they all are separate markets. And similarly, we can look at markets for services. So one service might be babysitting. So we can look at the babysitting market. Okay, the second important thing in this definition is the buyers and the sellers. So the buyers are going to be a group of people who determine the demand, and the sellers are going to be a group of people who determine the supply. Okay, so like I mentioned today, we're just going to mostly camp out on the demand side, but just keep in mind that there's always 2 sides of a market. There's people who are consuming the good, or there are people who are buying pencils, and then there are people who are supplying the goods. So there are people who are actually manufacturing and selling pencils. So as I'll show you in future classes, these 2 things kind of have to meet to determine what happens in the market. But for today, we're going to camp out on the demand side. Okay, so I'm going to skip a couple pages here to keep things short and sweet. So the first thing that's super important is something we call the law of demand. So again, I'm going to write and then we'll talk. So the law of demand says that if we hold everything else equal, and in economics we call this ceteris paribus, so in other words, if we don't let the wind blow, if we don't let anything change, we just freeze everything else in the market other than what we're talking about, then when the price of a good rises, the quantity demanded of the good falls, and vice versa. So I'm going to write and then we'll return to this. So all other things equal, which again is what we call ceteris paribus in economics, which is not English if you're wondering. Ceteris. I'll write this neatly since this may not be in your dictionary. Paribus is Paribus. Okay, when the price of a good or service, but we'll just put in good here, rises, the quantity demanded falls. And I should add in the quantity demanded of the good. Again, we're looking at a particular goods market. And it also works in reverse. So, and when the price of a good falls, the quantity demanded of the good rises. lots of writing today. Okay, so let's just pick this apart a little bit. So the law of demand says if you take the world and you don't let anything change other than the price of a good, then if you hold everything still and you take a good's price and you raise it, then there are fewer units that are demanded. So the quantity demanded will fall. So this kind of makes sense, right? So if you have a car and you are somebody is selling it, and nothing else in the world changes except the price of the car goes up, well, then what happens? Fewer people wish to buy that car. And works in reverse. So if you have a good, so say, for example, you're selling cookies at a bake sale. If you take the price of the cookies and you lower it, what happens? You get more customers. So the quantity demanded of the cookies rises. Okay, there's an important term here that I'm using over and over again. It's quantity demanded. And I'm going to make sure you have this definition because it's fairly intuitive, but there's kind of a nuanced element of it that I want to make sure is clear. So quantity demanded is the quantity of a good that buyers are both willing and able to purchase. So this is important. So quantity demanded is the amount of a good that buyers are willing and able to purchase. So the two important components of this are willing and able. So if we kind of link this back together, so the law of demand says if you hold everything else equal, ceteris paribus, then when the price of a car goes up, the quantity demanded of the car falls. What is the quantity demanded? It's the number of cars that people are both willing to purchase and able to purchase. So the idea here is if I am not on the market for cars, like if I don't need a car, then the price is kind of irrelevant to me. So if the price rises, I'm not really willing to buy a car in the first place, so I effectively have no impact on the market in terms of demanding fewer units because I wasn't willing to purchase a car to begin with. So the idea is that the thing that's being affected is the number of units that people both want to buy and are able to buy. So it's like the actual number of transactions that occur. Okay, so that brings us to the demand curve. So demand curve is going to have several properties, and when we plot this, you can't violate the rules, everything will kind of fall apart. So the first thing is what we plot against each other. So the vertical axis of a demand curve is always going to have the price along the y-axis, and then the quantity demanded is going to be along the x-axis, or the horizontal axis. Okay, recall the law of demand said that if the price of something goes up, then the quantity demanded will fall. So think about 2 points along a curve that would have to follow this property. They would have to be points that look something like this. So we can do that kind of extrapolation. So this is consistent with the law of demand because the law of demand says if you start somewhere, perhaps there, and that coincides with a particular price and a particular quantity, then if you increase the price, then you get to a new coordinate where the price is higher and the quantity demanded is lower. And if you just back up, the same thing works in reverse, which is consistent with the law of demand also. So the law of demand also says if you have a good and you take the price of that good and you lower it, what happens? Well, the quantity demand goes up. Okay, just to be incredibly explicit about this, in case you're not super comfortable with curves and graphs, all a line is a sequence of coordinates. So along this line, there's a coordinate there, there's a coordinate there, there's a coordinate there, and then everywhere along the line. Each of those coordinates corresponds to a particular Q and a particular P. So just redraw this one more time. So for instance, if we're kind of picking this particular coordinate right here, that goes with a price and a quantity. So this demand curve tells us all the combinations of price and quantity that go together. Or in other words, this dot tells us that if the price were this level, then this is the number of units that people would demand. The curve also tells us, because there's a dot there, that if you raise the price up to this level, then at this price, then this is the number of units that people would demand. So the curve is informative because it just tells us all the combinations of price and quantity that would exist in the world if you had ceteris paribus, or if you had nothing else changing other than the price. So the idea is if you move the price up and down, what happens? You get movement in the number of units that people want. Specifically, if you make something more expensive, people demand less of it. If you make something cheaper, people demand more of it. Okay, so that's what a demand curve looks like. I'll point out real quickly, demand curves don't have to be linear. I'm drawing it linear just because it's a little bit easier to think about that way. But there's nothing that says a demand curve has to be linear. So you could have demand curves that look a little bit convex. You can also have demand curves that have kind of like weird kinks to them. But what's important is that the slope is negative, or that there's falling down, or there's a negative relationship between price and quantity. Okay, so that is the demand curve. Now let's think about how we get a demand curve for an entire market. Let's erase and start at the top. Okay, a market again is composed of a whole bunch of different people. We have on the demand side a whole bunch of different buyers. So if we're thinking about a market demand curve, then what we're really thinking about is the demand curve that reflects individual people's demands, where you've got multiple people. So what a market demand curve is going to be is a summation of all the individual buyers' demand curves. So it's the sum of all individual buyers' demands for a particular good or service. So again, we're thinking about one particular market. Another way of thinking of this is the market demand is how much everybody in aggregate would demand as a quantity if you had a price to a particular level. So for example, let's say the price of t-shirts is $15. The market demand curve would tell you how many total t-shirts people demand across all people at a price point of $15. So another way of thinking of this is it is how much everyone, and then I'll put to reiterate this together, would demand at different prices. Different prices. Okay, so this is pretty intuitive, hopefully. The last thing I'm going to put up here is just kind of memory work, and then I'll show you how it works. So when you're deriving a market demand curve, what you might think of doing is drawing an individual demand curve for each person and then adding them together. That's a perfectly good way of doing it, but when you do that summation, you have to add people's demand curves horizontally. So this horizontal component is super important. I'm going to write it so it's in your notes, and then I'll show you what it looks like. So in your notes, you need to write to derive the market demand curve. We sum individuals' demand curves. And then here's the important part, horizontally. Okay, think about just a minute what a horizontal addition would mean. So I'm going to make a little picture here and then I'll enlarge it in a minute, but this is just to kind of get the point across. In the demand curve, you have price against quantity. So if you're adding something horizontally, well, what's along the horizontal axis? It's quantity. So the idea of this summation is we're going to peg ourselves at a particular price level, and we're going to have a whole bunch of these little graphs, one for each individual, and then each individual is going to be exposed to the same price point. We're going to figure out for each individual what their quantity is. And then in the market demand curve, we're going to take each of these quantities for each of the individuals and just kind of keep on tacking them onto each other and then horizontally sum them. Okay, in case that made no sense at all, I'm going to give you a concrete example and then you can see how this works and then you can practice it in a minute for the exercise. So as the example, let's think about the market for ice cream cones. Okay, so flip another page here so I can stay up to date on it. Okay, so we have, I'm going to draw a table and then we'll draw the graph. So in the table, we're going to have the price of ice cream cones. I'll just put the price of cones. And let's just think about various prices that you might charge for ice cream. So you could charge nothing for it. You could make it free. You could make it 50 cents. You could make it $1. You could make it $1.50. You could make it $2. You could make it $2.50, and then you can make it $3. I'll stop there. And let's suppose we're thinking about one individual to start with. So let's call this guy Al, and let's think about Al's quantity demanded of ice cream cones. Okay, the law of demand says, and this is true for an individual's demand curve or a market demand curve, that as the price of something goes up, people demand less of it. So if the price starts out pretty cheap, then if something's cheap, how many units of it do you want? You want a pretty large number of units. So let's just suppose that for Al, if the price of ice cream cones is nothing, then he demands 12 ice cream cones. If it's 50 cents, he demands 10. And we're just going to kind of make this a linear demand curve. And if the price gets up to $3, that's too expensive for ice cream cones, so Al doesn't want any ice cream cones. Okay, I'm going to draw down here. So in your own notes, I would move down a line and start drawing pictures. We're going to keep on tacking on rows on the table. Okay, Al's demand curve. Again, it's going to have price against quantity. And what we saw was that when the price was $3, he did not want any. So there's going to be a coordinate right there. And we can do this for each combination of price and quantity. So again, a demand curve is just a series of coordinates. Price and quantity coordinates, we have a series of coordinates. We have this coordinate, which is a price of 0, quantity of 12. This coordinate, which is a price of 50 cents, a quantity of 10. And so forth. So if we just keep on going, I'm going to just kind of selectively put in dots, but you could put in all the dots. If the price is $2, how many ice cream cones does Al demand? He demands 4. So we're going to have another coordinate here. If the price is $1, he demands 8. So we're going to have another coordinate there. If the price is free, he demands 12. So we'll have another coordinate there. And then there's also intermediate dots. And this is Al's demand curve. Okay, so far so good. So now let's think about somebody else. So somebody else might have an entirely different demand schedule for ice cream cones. So let's think about someone named Bob. And let's look at Bob's quantity demanded at each of the same price levels. So let's assume that Bob doesn't like ice cream as much as Al, and so if the price is free, he only wants 7. And if the price is 50 cents, he wants 6, and let's just keep on going down by 1. And so if the price is $3, he wants 1 ice cream cone. So this is kind of his demand schedule. Well, we now have a new series of coordinates. So now we have one coordinate that says in Bob's demand curve, when price is 0, quantity is 7. When price is 50 cents, quantity is 6, and so forth. So we can plot that, and we can get Bob's demand curve. And again, it's going to have price against quantity. So for Bob, when the price was free, he wanted 7. So we can go over 7 units. And he's got one coordinate there where quantity is 7, price is 0. He has another coordinate at 50 cents and 6 units. And then if you just notice here, the slope is positive, so we can just kind of like extrapolate since the slope is positive all the way down. And what we would find if we plotted each of these coordinates, I'll plot one more and then connect the dots. If the price is $3, he would demand 1, and there's going to be dots down here. So this is Bob's demand curve. Okay, so what we have so far is we have 2 demands. We have Al's demand for ice cream cones. We have Bob's demand for ice cream cones. And what we would like to calculate is what is the market demand for ice cream cones if you just have these 2 guys in the market. So in this column out here, let's see if the blue marker works better. We're going to have market, the market quantity demanded, which is also going to be the market demand. I'll start there. So this is going to be the market in total. Well, okay, let's start with the table. The table is easiest, and then we can move down to the graph. So the market consists of 2 buyers. We have Al and Bob. If the price of ice cream cones is free, well, Al goes and gets 12 cones. Bob gets 7 cones. So in the market, how many units have been demanded? You just add up these 2 numbers. And at a price of 0, the market demand is 19 units. At a price of 50 cents, Al demands 10, Bob demands 6. So in total in the market, there's a demand for 16 ice cream cones. And we can just keep on going down. So in your notes, keep on doing the addition. We're just adding up the quantity demanded for each buyer in the market. So 13, 10, 7, 4, and 1. Okay, note that we now again have another series of price and quantity coordinates. So now the first coordinate says when the price is 0, the quantity demanded in the market is 19. That's one coordinate. Another coordinate is when the price in the market is 50 cents, the total number of units that are demanded in the market is 16. And each of these combinations gives us a separate coordinate, and we can just plot all of these coordinates on the same graph and get the market demand curve. So if we do that, then we can get the total market demand and it's the same idea as before. So we'll plot the price against the quantity. And recall that we said that when you do the summation, you have to do it horizontally. So what does that mean? All that means is we start with a given price level, we peg it, and then we add up horizontally how many units are demanded. So let's start with 3, the price of $3. Well, at a price of $3, the first horizontal nudge is 0. The second horizontal segment is 1. So if we're adding 0 plus 1, that gives us 1. So there's going to be a dot there. And that's consistent with what we have here. So at a price of $3, there's 1 unit. Okay, we can keep on doing this all the way up or down the table, depending on which direction you want to go. So if we look at, for example, a price of $2.50. Well, in Al's market, at a price of $2.50, he wanted 2 ice cream cones. In Bob's market, at a price of $2.50, he also wanted 2 ice cream cones. So over here, at a price of $2.50, we went over 2. Over here, we went over 2. We're adding horizontally, so if you go over 2 and you go over another 2, you've gone over 4. That is consistent with the 4 we get over there. So at a price of $2.50, we're going to go over 4 units. And we'll get a dot somewhere in here. And you can just keep on doing this all the way along the table. So for the sake of time, I'm going to spare you the tedium of doing that. Let's do one last one, and then I'll give you the exercise. So the last point along the trail is we have a price of 0. At a price of 0, well, Al wants 12 ice cream cones. Bob wants 7 ice cream cones. In the market, we're adding up horizontally all the quantity demanded. So 12 plus 7 is 19. Again, that matches. So at a price of 0, again, not drawn to scale, we'd have a dot over here at 19. And then recall that each of these is also going to correspond with a dot. So once you get all the dots, you just connect the dots, and that gives you the market demand curve. Okay, so that's a real short and sweet introduction to demand curves. For the exercise, I'm going to give you a situation where you also have a market with individual people, and I'm going to have you derive the market demand curve. Okay, as I'm erasing, let me give you one quick side note. So since today is an asynchronous lecture, we're not going to have a question period, since I can't be online 24 hours to accommodate whatever time you want to watch us. So if you do have questions about this, just reach out to me and I'll try to answer them. But I'll save you the 10 minutes of questions and we'll just jump right into the exercise. Okay, so the exercise question is, suppose we're now thinking about the market for cookies. We'll do ice cream and cookies today. And let's suppose in this market you have 3 people who are buying the good, or you have 3 demanders. So we'll just keep the same names for simplicity. So the exercise is, suppose there are 3 individuals, and we'll call them, again, Bob, or Al, Bob, and then the third guy will be Charlie. So I have A, B, and C. And let's suppose that they demand the following number of cookies at each price. Okay, so here you'll just have to recreate the table. So we're going to have in the first column the price of cookies, or the price of a cookie. And then the second column is going to be Al's quantity demanded, then we're going to have Bob's quantity demanded, and then we're going to have Charlie's quantity demanded. Okay, the prices here, I'm going to make them simpler, so it's going to be 0, 1, 2, and 3. If each cookie is free, then Al is going to want 10, Bob is going to want 11, Charlie is going to want 12. If the price of each cookie is 1, Al is going to want 5, Bob is going to want 5, Charlie's going to want 6. If the price of each cookie is $2, then Al's going to want 3, Bob's going to want 4, and Charlie's going to want 5. And last, if the price of cookies gets kind of out of control and it's $3 per cookie, Al doesn't want any, Bob will just take 1, and Charlie, he really likes cookies, so he'll get 3. Okay, this is kind of a 2-part exercise. I'm going to ask you to do one part on your own and not turn it in, and then do another part and turn it in. So part number 1 is I want you on your own to draw the picture for the market demand curve for cookies. So again, what you would need to do here is you would effectively need to make another column here that says market. And then at each price level, you would just need to add up the quantity demanded by each individual, and that would give you the market quantity demanded. Okay, with that final column, you would take the combination of the price and the quantity in that last column at each price point. That would give you 4 combinations, or 4 dots that you could plot along a price quantity grid. You would just plot those 4 points and then connect the dots. FYI, if you don't get a linear curve, that's correct because I didn't make the numbers, except you'll get a linear curve. So that's step number 1. Just do it on your own. You do not need to put in the graph in Blackboard. Step number 2 is what you need to put into Blackboard. I would like you to answer, at a price of $2, what is the quantity demanded of cookies at in the market? So if you've done step 1, then you already have the answer to step 2. So just type into Blackboard a particular quantity demanded in the market, if cookies were being sold at a price of $2. Once you're done with that, you are good to go for the day, and I'll see you back for next class.